This question belongs to the topic engineering mechanics from the subtopic free body diagrams. An attempt is made to pull a roller of weight W over a curb step by applying a horizontal force F as shown in figure. The coefficient of friction between the roller and the ground, including the edge of the step, is mu. Identify the correct free body diagram of the roller when the roller is just about to climb over the step. Okay, so here is the roller diagram given to you. Here is the roller diagram given to you. And now you are required to pull this roller. Now you are required to pull this roller over the step. Over the step. So now when you are pulling this roller over the step, when you are pulling the roller over the step by applying force F, F force will be there. There will be force F present, right? And what else? There will be weight acting downwards. There will be weight acting downwards, and due to the step, there will be a reaction along the line joining center. Due to the step, there will be a reaction along the line joining center. Okay, it will be extended up to center. It will be extended up to the center of the roller. So this will be R. This will be R. So now if you examine the options, so in the first option, your force system seems to be like this, but there is, when you are trying to draw a free body diagram, you are required to isolate the body from the connections. You are required to isolate the body and from the connections and magnify the forces, active and reactive forces are present. So in the option A, the body is not isolated. It is still resting, still there is an information relating to horizontal surface which is given in the diagram. So option A cannot be correct. Option B, option B, if you see, there will be W, R and F. So and moreover, there won't be any contact at this point. There won't be any contact. No contact at this point. Once it is that. So no contact means no normal reaction. So no contact means no normal reaction. Now coming to FBD of C, you might put the question that, sir, it is rolling about that point, it is undergoing rotation, some rotation about that point. So this surface may experience some friction force. Yes, of course, it may experience some friction force or tangential force, right? But here it is rotating in which direction? It is rotating in clockwise direction. If you are trying to pull by F, it is rotating in clockwise direction. So friction force has to be in opposite of the nature. So but in option C, it is not given that. The direction of friction force is incorrect in option C as well as in option D. So the correct option which you are left with is only the option B. Where you will have forces R, W and F, right? So in case if you consider the effect of friction force, the direction of friction force in option C and D is given incorrectly. So it should be opposite to the direction of rotation. So opposite to this, it has to be upward, and here you cannot have the friction force. Here you cannot have the friction force because it is losing the contact. So option D is also omitted, right? So B will be the correct answer. B will be the correct answer, right? So this is the end of the answer.